Good day, sir. My name is Akonji Sodi Kolawide, CSC 2022-051. So this is my lab report. So my question 5, I'm told to write a program that reads a file, quadratic equation, coefficient, and determines the number of real roots for each line. So what I'm just to do is to check for the using the discriminant stuff. So if it is greater than zero, it is real, and yeah, it is real, and if it's less than zero, it is not real. And so what I'm just to do is to save is to create a .txt file that has I will just maybe as I want. Like, but what I used was I made an equation.txt file. This is it here. So it has like three equations. So I am to read the coefficient of each value, and this is my discriminant. This is the formula. If it is greater than zero, it is real. Else, if it is equal to zero, it is only one real root, and if it is less than zero, that is negative. There are no real roots. So this is the error there to catch. This is the algorithm there to catch error. And so, of course, this is the output. This is my flowchart. So I start, then open file. So if there is error, it goes to file not found and end immediately. And if error is not found, no, then it continues this way. It continues and prints it. And this is my algorithm. I start and impute. So I read each line of the file, then process it, then using the formula check if it is greater than zero, if it is equal to zero, and if it is less than zero, and I display my output. So what interested me most is reading equations from a file, applying mathematical logic programmatically. It took me about 25 minutes to write test because it was quite long. So most challenging part was the trial and error part. Yeah, I had to think a lot. So in overall impression, the task was a practical application of file handling, conditional statement, and mathematical reasoning in Python. On lab 6, I'm told to write a function to calculate the volume of a sphere given its radius. So using the formula, so I'll just import maths. So then I'll require the user to enter the radius. So this is it here. So enter the radius of the sphere. This is how it works. So I enter the radius and calculate it using the formula of the volume, which is 4 by 3 pi r cube. So this is the flowchart. I start the program, get radius from the user, then calculate the volume, then print it. So start input just like the flowchart to the algorithm is same. So I found it interesting how a simple mathematical formula could be applied directly in code to solve a real world problem. Using the mouse model access pi and made the program more accurate. It took me about 10 minutes because I used the maths library, and of course it was more efficient and easy to catch error. The only challenge was remembering to import maths module. Without it, using maths.py would be resulting to an error. So the program ran smoothly in turning the US input. Of course, I tested it. The questions were straightforward and practical. It helps reinforce how mathematical operations and functions work in Python. Thank you very much, sir.